limited. There is a heck of a lot more to learn beyond what's in this class, even at the end user level. So the way these classes work is they start with me telling you what I'm going to tell you with a PowerPoint slide deck, and then I'm going to go ahead and show you stuff hands-on in the NetBrain Thin Client. This will take about 90 minutes, maybe a little more, maybe a little less, depending on how many questions we have. Speaking of questions, the whole point of doing this live and in person is to for you guys to ask questions, for this to be interactive. So please never, ever, ever be shy about asking questions about what we're discussing. And there's two different ways you can do that. One is I have the chat function for the Zoom bridge open on my side monitor. So if you want to ask questions in text, you can do that right over there. And I should see those hopefully sooner rather than later, depending on how well I pay attention. The second thing is you should have the ability to unmute yourselves and just ask questions verbally. So I will be pausing every so often to specifically solicit questions, but you don't need to wait for that. If there's something that's immediately relevant, just cut in, interrupt me. I don't mind in the least, because if you guys aren't understanding what I'm saying, then there's really no point to any of this. The one caveat I'll give you is if you have questions that are about NetBrain but not directly relevant to what we're discussing at the moment, just don't forget about those. Just save those for after class, and after class I will talk about whatever you want for as long as you want, as long as it has something to do with NetBrain. Okay. So first of all, there is a class lab for the NetBrain environment, and this is a real live NetBrain deployment that is available to you 24/7, 365. And like with any NetBrain deployment, you access it with a web browser. I am going to be going a little fast for you guys to follow along click for click, but hopefully later today or tomorrow we'll be uploading the workbook for this class. It's in final peer review right now as we speak. So you open Chrome, Firefox, or Safari, ideally one of those three. Those are the three that our dev team certifies it'll absolutely work with. Any other web browser should work, but your mileage may vary. More specifically, you may get some sort of minor GUI glitches, in my experience. So you go to class.netbraintech.com, and let me show you how this works. So if we go over here, we go to class.netbraintech.com, and so in the class lab, you guys are not going to sign on with a normal user pass. What you're going to do is you're going to click this button down here to sign on with your NBU account via single sign-on. If you do not have an active NBU session, as indeed I did not, it kicks you to the front page of the NetBrain University system, which I'm assuming we're all familiar with because we're here. So let's go ahead and log in. And then once we're in here, we can either just click the lab button down here or just go back to the URL, same difference. And then we hit the button again. So we see we don't need to have an NBU tab open. We just need to have a session active in our browser. And now I'm signed in via single sign-on. And you have, I won't say you have the run of the lab. Basically anything I can let you guys do that won't accidentally break something in the lab environment, you're allowed to do. So you have quite a few permissions. Go ahead and explore that to your heart's content. So obviously I can't let you in the back end, for example, much as I'd love to let you play around back there as well. So I'm going to sign out of my SSO thing because I am actually the administrator for this system, so I have God mode. So I'm going to sign in like that because we might have questions like that later, or that deal with that later. Okay, so if anyone's having trouble accessing the class lab, just let me know after class and we'll get that sorted out. All right, so what is this thing? Why are we here? NetBrain is an adaptive network automation platform. Fantastic. What does that actually mean? The best way to explain NetBrain that I've come across is to start at the beginning. And the beginning for NetBrain was a couple of network engineers who were just sick to death of building and rebuilding Visio diagrams by hand. So they decided to make a system to do it for them. And they came up with the original NetBrain. So NetBrain got its start as not an entire platform for automation. It got its start simply as a tool for network mapping and documentation. It still does all that. Now, the way that that works is NetBrain's going to pull together a complete data set for our entire network. And when I say that, it's going to be talking to our traditional devices, routers, switches, firewalls, etc. It's going to be talking to our software-defined devices via API to their controllers specifically, and also for cloud-based parts of our network, it's going to be talking to them, again, via API to the controllers principally. For traditional devices, it's actually going to be, excuse me, it's going to be talking to them via CLI and SNMP. It's going to be pretending to be a network engineer, essentially. It's going to log in, pull show commands, pull config files, a little bit of SNMP as well, and it's going to take all that data. It knows how to talk to all different operating systems, of course. And what we wind up with is a complete database of all of our network design data in the NetBrain system, a complete database all in one place and in one format. Once we have that, then the system can calculate what our network looks like, both logically and physically. So this brings us to an important point. NetBrain operates at layer 2 and layer 3 per the OSI model. We don't really deal with layer 4 and up. So just be aware of that. Now, what we generate is what's called the calculated topology, which is kind of an overall picture of what the network looks like. I like to think of it as the system having in the back of its mind a complete and total understanding of how the network is put together, again, both logically and physically. Then, as we'll see, we can map out whatever the, well, we'll get to that in a minute. We can map out whatever part of the network we're interested in right now, and this is what's called a dynamic map. So that's as far as NetBrain originally went, being able to produce these maps on demand, and of course an inventory report and some export to Visio and things like that. All very, very powerful and still all there and still all incredibly useful. But once we had perfected that, what we realized it was that there was actually something we were in a pretty decent position to address, which is an overall issue with our industry as IT, which is that when we're wanting to troubleshoot or verify the design configurations or whatever, we have to go device by device individually and pull information. And this is, basically we have no middleware for network operations is what it boils down to. We have to be our own middleware in addition to being users operating traditionally. And this is obviously something that can be done. We do it every day, but it's incredibly inefficient. So what if we could turn this tool that has a complete view of the network into an entire platform that allows us to gather information seamlessly? Because what we realized as we started experimenting with overlaying different data sets on these dynamic maps, we realized that a network map is the ideal GUI for network operations in general. Because whenever you put data on a dynamic map directly or just next to a network map, you automatically put it into context. And so what we can do is we can pull whatever part of data we want very easily, and the map is our user interface. So being able to pull data sets is great, but there's also, typically once we pulled it, there's also analysis we want to do. And again, this is the sort of thing that's best offloaded to a computer, ideally. But what exactly I want to pull and what exactly I want to do with it in terms of analysis, what I want to do is different from what Asra is going to want to do, different from what James is going to want to do, from Patrick, from Tom, etc., assuming we're all working for different organizations, or maybe even if we're on different teams in the same organization. So how do we build NetBrain so that it can accommodate anybody's needs out of the box? And what we quickly realized is we couldn't. So what we did instead was we packed a bunch of really powerful basic tools in out of the box, but then we made some frameworks, some automation frameworks, to allow us to build our own automation. In other words, to teach NetBrain how to do whatever tasks we need it to do on a regular basis. And okay, customizable automation, that's great, but that's nothing particularly new in the IT space. But this isn't just customizable automation, it's adaptive automation. And what I mean by that is there's no coding or scripting or anything like that involved. It's all point and click through a user interface to build this stuff, and it's still really, really powerful. So, because, a lot of people simply don't have time to learn coding or scripting, and then there's, of course, a pretty decent subset of network engineers like my humble self who can't write a line of code to save our lives. That's kind of why I went into networking instead of software development. But anyway, not enough about me. The point is that it's very, very easy to teach NetBrain how to do what we want it to do. And this is the bottom half of the part of the slide we're seeing here, where we teach NetBrain about not only how to find the symptoms of common issues in our network, but also we teach it what the network is supposed to look like in terms of different elements of configuration. And then between the actual picture of what's going on in the network and these checks that we're programming in, these automation, we're able to bring together what we call the Problem Diagnosis Automation System, or PDAS. And the idea behind that is that we're using this automation engine, and again, with our specific programming tailored for our specific environment. And I use the word programming advisedly, not coding. So we're giving it instructions, but we're not coding or scripting. And then through the medium of these dynamic maps and our adaptive automation, primarily what are called network intents. And then there's also something called runbooks, which is how we actually tell NetBrain to do stuff as we're working with it. And we'll get into all this in class. And ultimately, the goal is to be able to do all the same stuff that we normally do, but to do it harder, better, faster, stronger, as somebody once said. So as we're thinking about how do we want to use NetBrain, don't be thinking about, okay, how do I twist my workflows to suit the power of NetBrain? You're thinking, how am I going to use NetBrain to enhance my existing workflows? Because NetBrain is designed to be adapted to the way that you work, not the other way around. Okay? So that's the basic overall pitch of what we're doing here. Any questions about anything that I've discussed up to this point, folks? Okay. So in terms of programming in, how to respond to different things, we tend to have a lot of the same issues over and over again. So we start with that, and it can actually have a disproportionate amount of effect on how much time we need to spend troubleshooting stuff, because if we can automate the solution of our top 10 time wasters, so to speak, or the top 10 things that eat up our time, then we can have a huge impact on not only our mean time to repair, but therefore we gain back a lot of time that we can use to do other stuff that needs to be done. And so this automation that I talked about, not only is there collaboration functionality built right into NetBrain, but any of this automation that we build, it can be triggered externally by a call from another system. It can be triggered internally by timers or other conditions within NetBrain, and it can also be triggered manually by us as the users. And any automation we build can be used in all of these three ways, even at the same time. So what you might get if at the sort of the extreme end of integrating this with other systems and building it out is you might get it where it's tied into our ticketing system like Snow or similar, and into our monitoring and management systems like BMC Remedy, PRTG, whatever. And so when particular types of tickets are submitted or particular types of issues are detected, we'll have set this up ahead of time, of course. We'll have told it to reach out to NetBrain and trigger a particular set of data to be gathered by NetBrain automatically. And so the data relevant to whatever the problem is gathered automatically while the problem is in progress. And it also will typically set up what's called an incident within NetBrain, which is how we collaborate. And we'll get a lot more into this. And then we come in as the users interactively, and we not only work with the data that was gathered by the trigger, but we can also pull whatever we need in the moment and ultimately find the root cause of the problem. And then once we've remediated the root cause, we can put in place preventive checks to make sure that our design intent is being respected, or to make sure that problems don't come back, things like that. And ultimately, These can even feed back into a ticketing system, so it can make a virtuous cycle. So that's an example of how this can work at the